Hello, and welcome to VSkap Science. I'm your host David, and today we're going to be talking about some of the interesting properties of water. Now, I'm actually going to get outside and do an interesting experiment in my eyes. We've all seen boiling water thrown into super cold air. Well, if you haven't, this will be a chance. It looks really cool. Now, I'm going to mix this experiment up and try a couple of different things. So, the reason that hot water turns so spectacular in cold air is that hot water actually cools faster than cold water. Now, I'll get into an explanation after we've actually done the demonstration, but I'm going to test whether cold water will do the same thing. And today we've got a super cold day. I think it's in the single digits. I think there's a high of 11, so it'll be pretty spectacular. So we're going to try hot, probably boiling water, we're going to try cold water, and we're going to try salted boiling water. Now, the reason I think salted would be interesting is because salt, when put into water, raises the boiling point, so we'll get the water even hotter, but it also reduces the freezing point, so we'll need to get it even colder for it to turn into a solid. So, what do you guys think will happen? Personally, this is before I've done any of the actual shooting or demonstrating. I think the boiling water will work just as expected. I think the cold water will get a little bit of something, but it's definitely not going to be as impressive. And for the salted boiling water, I think it's going to be even bigger because, as I said, we're going from even hotter to pretty sure the air is going to be cold enough to still bring it down and turn it into some sort of ice. So, let's see, make your predictions, and let's go. Alright, so I've got our pot of boiling water here, and it's, as I said, very cold, so let's see what happens. Definitely got tons of steam. Pretty impressive. Let's see if that happens with cold water. Alright, so we just worked with boiling water. Now we've got some room temp to cold water. Let's see if it acts any different. Well, it was just water. I guess that's why they use the hot stuff, to show the big temperature difference and the big gradient. So, let's see if we can pump that up using the salted boiling water. So now I've got the salted boiling water. It's probably hotter than 212 degrees because, as we said, salt raises the boiling point of a liquid. Let's see how it looks when we toss it. Here we go. Okay. I am thoroughly impressed by that. Hopefully that was all caught on screen pretty well, but there was a ton of it. Alright, let's go back inside and talk about why all that happened. Welcome back inside to a warm house. Now let's actually take a look at what happened. Something you guys might already know is that hot water can actually freeze faster than cold water. If you have a cup of 150 degree water, it'll turn to ice faster than a cup of 75 degree water. Now, why is that? Well, simply put, because density. Density is the amount of stuff that takes up a certain amount of space. So, if you have a cup of that 150 degree water, there are actually going to be less molecules than if you have a cup of 75 degree water. So, if there's less actual molecules in the hot water, it takes less energy, it turns out, to bring it all the way down to 32 degrees Fahrenheit than it would to take the 75 down to 32. So let's look at how this actually happens, and to do that we need to look at water on the molecular level. Now, water is H2O, or as I wrote, H2O1, to show that every molecule of water has 2 hydrogen atoms, right here, and 1 oxygen atom, this big blue one. Now, oxygen will actually pull the electrons that these two share with the oxygen closer towards it because of something called electronegativity, which, if you want me to, I can cover in another video. But that means the electrons are slightly closer to the oxygen, which means that the oxygen is going to have a bit of a negative charge, and the hydrogens therefore are going to have a bit of a positive charge. So every water molecule has a negative side and a positive side. Now, these can actually line up with each other. For instance, if these two molecules are near each other, the hydrogen that is positive and the oxygen that is negative are going to have a slight attraction for each other. That could also happen here. That might even happen here, though fairly weakly due to the positioning. So this means that water will actually attract each other and stay really, really close. Now, as water will heat up, those attractions can start to not be as strong relative to how much energy all these molecules have. But as they get closer together and they get colder, their density will actually get smaller. And there's actually something incredibly weird that happens. Water as a liquid is actually denser than ice as a solid. Now, that might seem like a weird concept, but I bet you have experienced it before. If you ever fill up a tray with water, you don't need to fill it up all the way in order to make ice. In fact, if you do, you'll actually have a layer of ice connecting all the little cubes. And also, if you ever fill up a water bottle and then stick it in the freezer, you want to make sure you don't fill it up all the way. That's because as ice forms, it expands. Now, that goes against most other substances. Mostly, as they get colder, they will come closer together. Now, because of this hydrogen bonding, the actual arrangement of the ice is not as strong as this hydrogen bonding, which means that the liquid, as I said, is going to be more dense, more tightly packed than the solid. But how does this relate to everything that was going on? Well, if I go back to density, we had very hot water, so there was not a lot of it compared to the amount it looked like we had. So it does not take a lot of energy to turn it into ice. So what we did, we threw the pot into the air, we let the water go, and since the air around it was so cold, it could transfer energy really quickly, and because we weren't dealing with as much water, and that water was fairly loosely packed, it could freeze very, very quickly. Now, why didn't the cold water work? Well, you guys might be able to answer this from what I've already said. The cold water, let's see if you know. Are you thinking about it? Think you've got it? Alright, cool. Well, the cold water would take more energy than the air around it could provide in order to get it to freeze, because there was more of it. And the salted boiling water, it was hot, but that means it was less dense, even more so. So even more of it could turn into steam. So that is how all that happened and how you guys can try that at home. I mean, be careful because you are working with boiling water, but in terms of do not try at home, that's not really one of those. So I hope you enjoyed the video, and it would be awesome if you left a like or even subscribed. Never know. And if you want any other type of science concept or question answered, you can leave it in the comments. You can message me if you have me on any social media. And otherwise, I hope to see you guys next time. Stay cool, stay tuned. I like this video. It was pretty ice.